Hello everyone, my name is Veera Neerukonda. Research topic that our group chosen is information governance on top of microservice-based applications. Microservice is a buzzword in present IT industry. A lot of companies are investing on migrating their monolithic application into microservice-based applications. As a DevOps engineer to a healthcare IT company, I deal with microservice-based application on day-to-day basis. I'm part of architecture team, DevOps team. I provision environments to run these applications. I set up continuous integration and continuous delivery pipelines for this application deployment process. So, as part of my DevOps journey, I'm involved in implementing logging, monitoring, tracking, data retention policies, etc. Well, I don't know the word of governance until I started this course, but I've been implementing governance in our organization on day-to-day basis. So I decided this topic would be, implementing what I learned in information governance in my work would help me in in a better way. So I discussed this topic with my team, and we collaborated with each other and worked on a specific area, wherein finding out key metrics that improves governance aspects of an application. We had taken a sample application, introduced defects in it, and identified key metrics that can be observed and customized as per business needs to provide to establish a good governance. So, without any delay, let's dive deep into the presentation. Before starting my presentation, I would like to give an overview what are the topics that I am going to discuss. So, I'm going to start with a basic idea on monolithic architecture and compare it with microservice-based architecture, and I will discuss key benefits of microservice-based implementation. Uh, Along with benefits, there comes challenges, security challenges, kind of thing. So I'm going to talk a little bit about security challenges that are part of microservice applications, and what are the best practices that can be enforced on this type of applications. And um, there comes the interesting part, that is microservice governance, which is basically I referred certain methodologies recommended, and I'm going to highlight those methodologies that are key for enforcing governance on top of microservices. And here comes the interesting part, wherein entire study is basically concentrated on. So, as part of our research, study is done on sample application with which is designed using microservice based application. We identified key metrics that need to be observed, and policies need to be enforced upon them. So these two points are the key areas where we entirely concentrated on. Finally, I'll share a couple of governance practices that I've been using, and what are the tools that I'm using to achieve them, and then I would like to conclude with a brief note. Let's imagine, you know, that we are building an e-commerce application, and it is a monolithic in style, that. So e-commerce application can include services like, application contains the services components, include UI, uh, which implements the user interface, along with the backend services for checking credits, you know account services, inventory services, shipment services, kind of thing. but all these services are running on top of a single web server like Tomcat, and it's which is linked with a database. So this is a style in which monolithic applications are there for a decade, and however, once the application becoming large, a lot of code, a lot of logic is implemented in around web server, it will be difficult to maintain, or else implement new changes in the code. So, you know, applications that are the application is deployed in a single monolithic application can be run on a single server. For high availability, they can be run on top of multiple servers, and implement load balance on top of them. So, you know, mm, these type of architecture comes with complexities, like, it's not easy to scale, or else implement it's not easy to implement any new change, or change the stack, change a component in a stack, or change a technology that's being used in the stack, kind of thing. And it requires that's nothing but it requires longer commitment to the technology stack. you know that's about microservice based applications, monolithic based architecture. So coming let's discuss about uh, microservice based architecture. So term itself says this, states that microservices. So microservice is not a product, it's just or a framework or a platform. It is a strategy to build distributive enterprise level products, software products. So microservice architecture benefits enterprises in multiple ways. Advantages include independent scalabilities, faster time to market, and easy software development cycle and maintenance. So, size of the microservice uh, is critical for the design of quality services. Microservice reduce vendor locking, and for example, you can have individual technologies used for each service. Overall, it helps in making choosing making it helps in choosing independent tools needed to develop a specific business functionality. So let's talk about service. Service in the microservice architecture is independent deployable component. Services are organized around fine-grained business capabilities. Service can be implemented using different programming languages, databases, hardware, and software environments, depending on what best fits to specific service. So, services are small in size, message enabled, bounded by context, autonomously developed, independently deployable, and decentralized, and built and deployed independently. So, basically, there is a saying that do one thing and do it well. So microservice based architecture basically allows that allows developers to concentrate on specific functionality, declare code, generate a better quality of code, and you know uh, uh, develop a functionality in a better way. When talking about benefits, there are as these distributed in nature, they comes up with benefits such as they can easily simple to deploy, because those are independent in nature, simpler to understand. So if a new employee joins, they can easily understand the logic specific to that service, and he can, you know, implement changes on the fly. Well, coming to reusability. So same logic, same code base can be reused across different applications. We have around 100 service microservices in our application, and those logics are used across 3 different applications, kind of thing. So reusability is very high, and so fast defect isolation, because as it's a small and small in nature, faster defect identification can be achieved, and even security scanning can be done on each microservice and generate a specific report, kind of thing. When talking about microservice security challenges, as as microservice applications are distributed in nature, it comes with its own complexity. You know, uh, uh, you know, with microservice architecture, there are 4 main areas to think about, which are design, implementation, and deployment and management. For example, as when talking about design, a specific microservice might need a certain dependencies. So we need to make sure standardized config file is maintained and declared in the code base. As far as deployment, we can enforce blue-green deployment, or canary deployment based on need, and deploy the specific code into production independently. Each of these areas would align with several security principles, such as targeted, standard, locking, multi-key, and elastic. So targeted in the sense like specific to the service centric kind of thing, and standardization. When as I was discussing, when you are declaring configuration, you should make sure config is maintained in a standard way across all microservices. Metadata is in place, and security scan is enforced, or API based authentication is enforced, kind of thing. So locking does include authentication between services, and data in transit need to be uh, you know you know transferred using by authenticating calls between services in a secure way. And as traffic grows, or as application usage increases, microservices need to be auto scaled or downscaled based on demand. These are the complexities or security challenges that need to be addressed when dealing with microservice based applications. Let's talk about best practices that can be enforced, security best practices that can be followed across microservice APIs and all. So, using TLS protection for all services. TLS stands for Transport Layer Security, and it's widely deployed security protocols that is used to secure exchange data over the network. TLS ensures that the connection to the remote endpoint is intended to endpoint through encryption, endpoint identification, verification, kind of thing. So we definitely needed access control on top of all these microservices. This will provide us with secure authentication and authorization. Another essential element of is encryption. So TLS comes with encryption, and uses the transportation layer to send encrypted data. Coming to OAuth, OAuth. OAuth 2.0 is an authentication framework that allows users to obtain admitted to a resource from a resource services. It is basically a best authentication method that can be implemented, adapted to microservice based applications. API keys can be generated which can be used between two services, and can be rules such as expiry can be enforced on top of those applications, kind of thing. So don't show sensitive data. So when dealing with microservices, we have a lot of config files. Developers usually do some mistakes like hard coding secrets or config files, kind of thing. So never include any secure data in the text formats. While working with sensitive data like PHI, PII data, we need to make sure that it doesn't be it's not declared in a plain text. All the passwords and the username should be masked during the with a strong during the storing process of storing data in a log or a record, kind of thing. So using multi-factor authentication, by using multi-factor authentication we offer users better protection by default. So as some aspects are hardened to steal them, instead of to overcome security attacks, to multi-factor authentication really helps. Along with the password, you can generate auto code, and in case of microservice, it's nothing but generating an API key and have a expiry for a certain time, kind of thing. So this can be addressed using OAuth. So protecting public APIs from denial of service. There can be attempts of sending overhead number of service messages within the specific microservice. To prevent such attacks, we need to set a limits of number of requests that can be served by a specific microservice for a given time. By doing so, we can achieve denial of service based attacks. And lastly, using encryption, data that is in transit should always be encrypted, and strong crypto algorithms such as RSA or blowfish can be used, and data can be encrypted and transferred safely. So let's talk about microservice governance. This is the heart of our topic. So microservice governance is a methodology or approach that we want to implement, that we want to enforce in a better way. So when talking about microservice governance, it's a methodology or approach that establishes policies, standards, and best practices for adoption of microservices to enable an enterprise agile IT environment. In a microservice world, developers now have the freedom and capability to experiment with the new languages, patterns, frameworks, data stores, and other innovative aspects of IT development. This can result in operational team feels like a level of discomfort when confronting a new experiments done by development team. Various views exist in regards with microservice architecture having no governance or a thin governance compared with service oriented architecture. Governance in monolithic are centralized. Decisions are made on top down. Rapid controls is maintained to ensure standards are in place across the organization within the application stack. Overall time, over time, this model degenerated, creating a stigma technologies in technology and architecture system. Microservice promotes a uh, model regarding technology stacks for supporting languages, tools, and data sets. So, by enforcing governance, strategic alliance of IT with billions business team can be achieved. Reusability of service and logic can be achieved in across different stacks of applications. An architecture, a microservice architecture of a service design and integration with enterprise users can be implemented. So, the key elements of governance are, governance plays a key role in this microservice environment, right? To, you know, the end result is to make sure, business requirements are addressed, and they are addressed in a faster pace, and with a better security and uh, better compliance kind of thing. So, if you see the diagram, DevOps been playing a major role to establish those governance practices. So, microservice adoption, adopts a decentralized governance system. These standards enables the teams to effectively build and deploy the code that has been created according to the individual governance plans. The goal of decentralized governance is to free dev team, allow them to allocate time to solve development problems effectively within the time manner. It is important to develop a DevOps mindset within the enterprise. This mindset enforces developers to control how their governed components are built and operated. Coming to our main topic, our study is based on sample application. Uh, you know, uh, ticketing sales application is chosen for which is basically helps users to reserve their tickets. So in a specific theater kind of thing. We implemented some bugs and bad practices so that it can be analyzed by our statistical analysis tool. There are 8 services in a sample application. On the other hand, real world applications have usually more service depending on the project requirements. You know, our services are API gateway, saloon, tickets, credit cards, debit card, coupons, SMS, and mailing services. Also, we have 2 external services provider named as a banking and sender provider. These are for payment, SMS, and mailing operation requirements. They are out of scope for statistical analysis. High level application architecture is given in the next diagram, but we assume DNS are dynamic in nature and discoverable by each services. Furthermore, data layers of services are designed suitable for microservice architecture and decentralized in nature. Information about microservice are labeled. Policy checks within unused resources are given in service details. RESTful API paths are formatted as declarative with a format of method, white space, URL, and dynamic properties such as ID, SID, CID kind of things. Resources and clients lists are defined in detail for each service. So, in our study, there are 3 measuring of test software quality in order to create suitable microservice architecture. So, which basically include the measurables include service size, service size, uh, service to service communication or compatibility, and bad practices. So, talking about measuring service size. Size of a microservice is a sum of resource count and resource count and client count. Resource count is nothing but services which can be identified using URLs. Client counts can be defined as number of connections that for the purpose of sending requests. Coming to service communication, our analysis is based on analyzing unused resources and unreachable endpoints in the microservice based application. Unreachable endpoint count is based on microservice that is not existing or not reachable. Unused resource count is nothing but microservice that handles that handles receive requests that isn't in use, but it's already declared in place. So bad practices, coming to bad practice, study include identify static URLs, long URLs, and bad practice in the policies between service across microservices. Long URLs is nothing but referring to service using long size of URLs. According to the finding, URL size is recommended to be less than 15 letters. In payment and coupon services includes resources that are not in use. In payment and resources services includes resources that are not in use. These services breaks the rules of having zero unused resources. One of the possible scenario in this case is that the developer can forget to remove unused functionality. Other is that the code base of those service can be released earlier than other services. So coming to ticketing service ticketing service has clients client. However, it does not exist in the application area. It includes a client that sends notification with the request of post. So in that case may additional motive functionality problem. If that might be a functionality problem. Possible scenario are that the URL may not be written successfully, or pushed notification service may not be established within the carrier list, but the ticketing service still have the unreachable clients into the source code. Even this customer does not does no longer have an effect on whatever terrible situation it is. Coming to camera service has useful resource to handle complex queries, but its URL violates our URL duration coverage. It is longer than 15 characters. It obeys that URL should have at least minimum maximum 15 characters. So it is having longer URL URL size. Ticketing service has a client to ship requests to mails carrier. The client URL is declared in a different code. The URL, if the mailing service lives up to another URL, ticketing service can have a mailing sender trouble. it methods that you could fail the production simply because of hard-coded URLs. Moreover, it's difficult to hit upon quickly those type of coded configuration issue. So static URL metrics that labels an awful practice may address shopping to be addressed. We are generating many situations for policy violation mentioned above. It is vital to understand that early detection and automatic examining with tuned guidance is helpful to manipulate software program best. By measuring all the parameters mentioned and enforcing governance practice on top of the microservices, IG's information governance can be applied on top of these microservice applications. So I would like to end this you know presentation by discussing a few areas where I implement governance in microservice based applications. So we use tools like Elk or Splunk to enforce logging. We log each and every activities between microservices and register calls, and we enable policies like how much what log need to be stored in which format. So for example, we enforce grok filters in elk stack to customize the log file and store it in a specific format. If the data has some PHI PII data, we implement encryption on top of the data and store them into our elk stack. mm, you know all this data that is stored in elk is encrypted. We use TLS encryption on top of data that is in transit between elk and file beat. We use SSL certs between them. you know uh, driving driving development sprints towards addressing stakeholder requirements. So this is the main key areas that can be achieved. We should development team should closely work with the business team and pick a specific feature that stakeholders are looking for, and develop the microservice and deploy based on need. you know Fix all issues that responded reported by customers. So I usually be part of hotfix deployments. So whenever we usually get feedbacks from stakeholders and fix them automatically. So continuous security and patching. On every month we do patching on top of any uh, you know uh, core OS as well as application softwares. Our application depends on Redis, Kafka, Elasticsearch kind of thing. We usually patch them based on new software releases kind of thing. So all these tools can be enforced on top of those metrics, such as you know static URLs, hard-coded values, or unused services kind of thing. So in this study, according to the characteristic features of microservice architecture, we discovered some gray areas. From this viewpoint, new metrics and policies were defined. These are resource count, client counts are defined as measure of service size. Unused resource count, unreachable endpoint counts are defined as a service interconnection compatibility issue. Static URLs, long URLs are defined as bad practices. So a sample application were implemented with some bugs, and bad practices are implemented as part of design in order to compile comply with these metrics, software were analyzed using statistical analysis tool, examined results, and expectations were compared with evaluation. The results are as same as expected. Although sample application is simple application, many problematic scenarios are generated and they are detected by the tool. There are more microservices than our sample automated sample application in real world. It is important to understand that automated software quality analysis management is important to make softwares under control. Also, running tunable policies upon software makers is more valuable and observable to prevent bugs and bad bad practices. So you know uh, uh, so our idea is to identify the key metrics and enforce the governance policies on top of them. And I would like to end you know this presentation by saying that development team need to closely work with leadership team and implement new technologies in a faster pace. That's what we are achieving using microservice based application. In this process we might have some loose coupling, security bottlenecks. By enforcing governance policies on top of microservice environment, we can achieve better software products kind of thing. These are a few references that I use, and this is the main IEEE paper that recommended these metrics and be referred to this, and used information governance practices and included in our research project. Thank you everyone for listening to this topic, and it's my pleasure working as a team, and we successfully implemented, learned about how to enforce information governance on top of microservice based application.